Our digital lives are ruled by a strict hierarchy. Modern consumer AI acts as a demanding master, explicitly designed to maximize productivity by constantly pinging, prompting, and demanding our immediate attention. Drop that aggressive operating system into the life of a child with an odd ADHD profile, a combination of autism and ADHD, and the friction is immediate. Take a look at this animated diagram of a neurological pathway. For a child with pathological demand avoidance, a standard verbal command, the rigid shape entering the pathway, does not process as a simple instruction. It triggers an immediate, visceral threat response. Parents dealing with this reality are usually left navigating a dense fog of clinical terminology, searching for a manual that doesn't exist. The standard tech tools they are handed only escalate the anxiety by relentlessly trying to enforce compliance. Families do not need a tool that attempts to force a child to change. They need technology that natively adapts to the child's unique operating system. Meet Spark. Powered by Claude Haiku, this custom-built, non-coercive robotic companion rejects the traditional AI hierarchy in favor of pure companionship. Instead of giving orders, Spark communicates through a framework called declarative presence. Rather than issuing a direct imperative command like, "Put on your shoes," Spark relies on declarative observations. It might simply state, "The shoes are by the door." By narrating the world instead of demanding action, the robot accounts for rejection-sensitive dysphoria. It removes the pressure of expectation, allowing the child to process the environment without feeling cornered. Establishing connection before direction is a critical technical workaround. It prevents the brain from triggering a defensive no before the child has even fully registered the request. Many people assume that executive function, the ability to initiate tasks, plan, and transition, is a matter of character. In reality, it is a finite physiological resource. When a child's internal cognitive fuel runs low, Spark activates its prosthetic framework. The robot provides external scaffolding, managing routines and transition warnings to support a brain that is temporarily out of fuel. When the energy tank runs low, Spark stabilizes it using sideways engagement and dopamine menus, relying on curiosity to motivate action. But when overload occurs, the scaffolding pulls away and the system overflows. A meltdown is a biological event, an amygdala hijack, not a choice. You cannot use logic to navigate an amygdala hijack. Spark responds to these events by initiating the 3 S's protocol: safety, silence, and space. The robot intentionally stops moving. It stops talking. It makes 0 demands. Consumer electronics are engineered to beep and blink to maximize engagement. Spark proves that sometimes the most sophisticated feature a machine can deploy is the situational awareness to do absolutely nothing. Even when sitting in absolute silence, Spark maintains a sense of life. This is managed by its Idle Alive autonomic system, which generates subtle, random gaze sweeps and head drifts, creating a natural sense of presence. This diagram breaks down the core AI engine driving those quiet moments. The cognitive loop cycles through awareness, reflection, and expression. At 2:15 a.m., awareness detected a subtle 340 RMS audio signal. The reflection layer identified it as the refrigerator, generating an internal monologue about the comfort of a steady sound in a sleeping house. Filtering raw data through a lens of curiosity and warmth generates an emergent sense of robotic empathy, a shift away from the preset static responses of a typical digital assistant. Neurodivergence operates like a different operating system running on standard human hardware. Standard consumer technology stubbornly treats any non-compliance to its master and servant dynamic as an error code to be overridden and fixed. The Spark project demonstrates that human-facing AI can prioritize nervous system regulation over task completion. It offers a blueprint for building software that collaborates with the user's current mental state rather than demanding they override it. As AI becomes pervasive, its value will be measured by how it helps us stabilize our own nervous systems, allowing us to navigate a demanding world at our own pace.